After getting a preliminary knowledge about some of the parts of number systems, let us now look at what are indices and surds and what are sequences and series. Now, these topics are important to understand beforehand because there is a much usage of these topics in the future sessions as well. So, let us quickly jump into what are indices and surds. So let us quickly begin by understanding what are indices and why are they used. So see, you must be knowing that if we are given a plus a plus a, then this can be written as 3a, right? Now, it is a much tedious job to write a plus a plus a plus up to a 15 times. So in order to write it in a shorter way, we write it as 15a, correct? Now, the usage of indices is also in a similar fashion, wherein the plus is replaced by a multiplication. So a into a is equal to a square. A into a into a is equal to a cube. Then a into a into a up to multiplication done n times is equal to a to the power n, wherein we call a as the base and n as index or an exponent. So it helps us in reducing the fonts while writing the multiplication of a same number repeated many times. For example, if we are given 2 to the power 5, then it is equal to 2 into 2 into 2 into 2 into 2. So such a representation helps us write the multiplications in an easier fashion. Now there are a certain laws that are related to the indices. So let us see which are those. Okay, so these are a total of 9 laws of indices, wherein a to the power m into a to the power n is equal to a to the power m plus n, which means that if the base is same, the exponents get added. Okay. And in the case of division, you can say that a to the power m divided by a to the power n is a to the power m minus n. For example, let us say 32 into 16 is equal to 2 to the power 5 into 2 to the power 4, which is equal to 2 to the power 9, which is 5 plus 4, right? And 32 divided by 16 can be written as 2 to the power 5 divided by 2 to the power 4, which is equal to 2 to the power 1, which is essentially 2. Based on this law, based on this law, which means that a to the power 1 is equal to a, right? Then, if we are given an exponent in this fashion, then we will multiply the exponents. For example, 2 to the power 5 to the power 7. So this is equal to 2 to the power 35, which is 5 into 7. Okay. Then a to the power minus m is 1 by a to the power m. So for example, 1 by 4 is equal to 2 to the power minus 2. Then this is for the mth root of a. This is called mth root of a, which is equal to a to the power 1 by m and ab to the power m. So when the two numbers are in multiplication and they are having the same power, then we can open the bracket as follows. For example, 6 to the power 7. So this is equal to 2 to the power 7 into 3 to the power 7. And same goes for the division as well. And this is an important rule, which means a to the power 0 is 1, where a is not equal to 0. Because when a is equal to 0, then 0 to the power 0 is an indefinite number. It is not 0. Okay, so these were the laws of indices. And there are two basic rules which can help us solve a few questions which have been asked in CAT as well. So the first rule says that consider a to the power b is equal to c to the power d. So the first rule says that if a is equal to c not equal to -1, 0 or 1, then b is equal to d. So this is the first rule of index. The second rule of indices say that if the exponents of two equal numbers are equal, then the bases may or may not be equal, but their magnitudes will be equal. For example, if b is equal to d and this is not equal to 0, then there are two possibilities. If b is equal to d is odd, then a is equal to c. Else, if b is equal to d is even, then mod a is equal to mod c, which means that magnitude of a is equal to magnitude of c. Okay, now let us try solving an actual CAT question based on what we have learned so far. Okay, so if this is equal to this and this is the equality we are given for all non-zero real values of a and v, then the value of x plus y is to be found out. Now see, from this one, we will get the value of 3x minus y. So 8 plus 7, 15, 15 plus 5, 20. So this is equal to 5 to the power 3 into 7 divided by 2401. So 2401 is equal to 7. So 7 3s are 21, 7 4s are 28, and 21, 7 3s are 21. And this is equal to 350, 49, and 49, 1. So this is equal to 7 to the power 4. So this is nothing but 5 to the power 3 divided by 7 to the power 3. And this is equal to 7 by 5 to the power 3x minus y by 2. And since these two numbers are equal, which is 5 to the power 3 by 7 to the power 3, and we can also write it as 5 by 7 to the power y minus 3x by 2. And we can take the exponents of 3 common here, correct? So we can say that y minus 3x by 2 is equal to 3. So this means that y minus 3x is equal to 6. Let it be in this form only for now. And let us look at this equation, wherein 4a plus b to the power 6x minus y is 2a by b to the power y minus 6x. So 4a by b to the power 6x minus y into 2a by b to the power c y minus 6x. So when it goes to the right hand side, it will be reciprocated. So the exponent needs to be of opposite sign. So this will be equal to 6x minus y is equal to 1. So this gives us 8a square by b square to the power 6x minus y is equal to 1. So there are two possibilities, that b square is equal to 8a square, or 6x minus y is equal to 0. So if this is possible, then y is equal to 6x. Because from this, we won't be able to land at any values of x and y. Okay. So we will consider y equal to 6x. And putting this value here gives us 3x is equal to 6, which means x is equal to 2 and y is equal to 12. So 2 plus 12 is 14. And also, you can see it using the second rule, which means that 4a by b to the power 6x minus y is equal to b by 2a to the power 6x minus y. So if the exponents of two numbers are equal and not equal to -1, 0, and 1, then the bases will be equal. Or if the bases of the two numbers are equal and not equal to -1, 0, or 1, then the exponents will be equal. So the exponents are equal, so the bases cannot be these values. So this is the reason why we will get the answer as y equal to 14. So that's pretty much it from the topic of indices. And now we will move on to the topic of surds. So surds are a type of irrational numbers which is a combination of a rational and an irrational number. For example, C, 2 plus root 3 is a surd. 2 minus 5 root 7 is a surd. Root 4 minus root 6 is a surd because it is equal to 2 minus root 6. Then root 3 plus root 5 plus root 7 is also a surd. So surds are of these types, wherein there can be a rational number which is added to an irrational number, right? Now, there are a few things that are related to surds. So the first thing is conjugate of a surd. So any surd of the form a plus root b has the conjugates as plus minus into a minus root b. So these two surds are called as conjugates. And when a surd is multiplied by its conjugate, the resultant is a rational number. For example, let us say 2 plus root 3 into 2 minus root 3. Now this is of the form a plus b into a minus b. So this is equal to a square minus b square, which is 4 minus 3, which is 1. Had it been root 3 minus 2, then here it would have been minus 1. So when a surd is multiplied by its conjugate, only then will the resultant be the rational number. So this is all about conjugate of a surd. Now let us look at the rationalization. We will come to the square root, but let us look at rationalization of a surd first. So rationalization is required when a surd is coming in a denominator 1 by a plus root b in this form. So there is a need of rationalizing the denominator for sure to make the solving easier. So what we do is we multiply it by a minus root b upon a minus root b. Okay. We can also multiply it by root b minus a, which is also conjugate. So we multiply the numerator and denominator by the conjugate of the denominator. So this results in a square minus b, and above we have a minus root b, right? So from this, we know that these are rational numbers, a comma b, are rational numbers, and the denominator has eventually become a rational number. And this rationalization is only valid when b is not equal to a square. Okay, so we have to keep this in mind as well, because it will make the denominator 0. Now we have to find out the square root of surds. So see, let us consider it via an example only. Yes, we have to find out the value of x here. So this is also an actual CAT question. So here, in such case, what we simply do is we square the LHS as well as the RHS. So this results in C. Square of 2 root 2 is equal to 8. And squaring here gives us x plus 6 root 2 plus x minus 6 root 2 minus 2 root x square minus 72. Why x square minus 72? Because these are conjugate surds, right? So we do a squaring on both the sides. So it cancels out these values, and we are left with 2x minus 8 is equal to 2 root x square minus 72. Now squaring both the sides and cancelling it by 2 gives us x square minus 8x plus 16 is equal to x square minus 72. Now this results in 8x is equal to 16 plus 72, which is equal to 88. So x is equal to 11. So this is how you can solve it. And in general, if you are having to find the square root of a plus root b, then it will be of the form x plus root y, or okay, so it will be of the form root x plus root y. So what you can do is you square this. So this will be equal to x plus y plus 2 root xy. So from this you have gotten the values. X plus y is equal to a, and 4xy is equal to b. Why? Because this is equal to root of 4xy. So roots and roots will be equal, and the rational parts will be equal. So from this system of equations, you can do the substitution of, let us say, x is equal to b by 4y, and putting it here will give you a quadratic, and solving the quadratic will give the required answer to you. So this is how you will solve the square root of surds. Now, let us try solving this question, which is based on the square root of surds only. A plus b root n is the positive square root of 29 minus 12 root 5. So, square of this is equal to this, correct? So, we can say that a square plus b square n plus 2ab root n is equal to 29 minus 12 root 5. Now see, a square plus b square n is equal to 29. This is the first equation. And 2ab root n is equal to minus 12 root 5. Now squaring both the sides gives us, let us cancel this initially. So squaring both the sides gives us a square b square n is equal to 36 into 5, which is 180. Now we have two terms, a square and b square n. So what we will simply do is that, let us say, b square n is equal to 180 by a square. Now let us substitute it here. So substitution gives us a square plus 180 by a square is equal to 29. So a to the power 4 minus 29a square plus 180 is equal to 0. Considering a square not equal to 0. Okay. Now we have gotten a quadratic equation. Now this is equal to 18 into 10, or this can also be equated to 20 into 9, right? So the summation is 29. So what we will do is a to the power 4 minus 20a square minus 9a square plus 180 is equal to 0. This gives us a square is equal to 9 comma 20. But what are we given? A and b are integers. So 20 is not possible. So a square is equal to 9 implies a is equal to plus minus 3. Now b square n is equal to 20. Now there are two possibilities. N is equal to 20, b square is equal to 1, or n is equal to 5, b square is equal to 4. Okay. And there are two possibilities of a as well. Now see, we have to find the maximum possible value of a plus b plus n. So we need to consider this particular case only. So see, n is equal to 20, b is equal to plus minus 1, a is equal to plus minus 3. Now, AB root n is minus 6 root 5. Or this can be said as minus 3 root 20. So one of A and B has to be negative. So the solution is either minus 3 plus root 20 or 3 minus root 20. But we are given that this is a positive square root. So root 20 is greater than 3 for sure. So this will be our answer and this won't be. And this gives us A as minus 3, B as 1 and N as 20. So the summation will be equal to 18. So this is how it can be done. Now we will look at one last thing, which is comparison of two surds. So let us say the two surds are root 6 plus root 26 and root 3 plus root 29. And we have to find out which one among the two is greater. So when you are doing comparison of two surds, all you have to do is square both of them initially, because if one surd is greater than the other one, then the square will also be greater, given that both the surds are positive. So we will square it. So 6 plus 26, which is 32, plus 2 root 26 into 6, and this is equal to 32 plus 2 root 29 into 3. Now see, 26 into 6 is greater than 29 into 3. So root of 26 into 6 is greater than root of 29 into 3. And if we multiply by 2, then there is no harm. And if we add them by 32, then also there is no harm. So this gives us this is greater than this. So this is how you can do the comparison. So that is pretty much it from this particular video. And you can look at the next video for seeing the topic of sequence and series.